Okay, in this lecture, we continue to look at examples for simple annuities. So I will continue with example 30. Dr. van Rooyen is planning to set up a private practice. She requires a loan of 500,000 rands, which is secured from a local bank at an interest rate of 18% per annum compounded monthly. Her budget allows equal monthly repayments of 15,000 rands, the first payment falling due exactly 6 months after securing the loan. Determine the required number of payments. Okay, so there are many things going on here. This is an annuity. It is a simple annuity because the compounding period is monthly and the payments are also monthly. And Dr. van Rooyen can only start to pay back this loan after 6 months. Okay, so we can draw this whole thing on a timeline. So the loan size is 500,000 rands. She can only start repaying at time T6. And in this case, we would like to determine the number of payments. So we don't know what our K is. We know that our payments are all equal to 15,000 rands. We also know that the interest rate is 18% per annum compounded monthly. So again, we will do it in two steps. The first step is to move the 500,000 rands to the start of the annuity. Remember, your annuity starts one time period before the first payment. So my annuity will start at time T5. So that is my annuity part. And from T0 to T5, I am moving a single amount, 500,000 rands. So in the first step, I will move this 500,000 rands to time T5. My interest rate, or my effective monthly interest rate, 0.015, and I move it 5 months forward. Okay, so that is then the present value that I will use for my annuity that starts at time T5. Okay, now in step 2, we would like to solve for K, the number of payment periods. We start out with the basic formula for the present value of an annuity. Okay, the first thing would be to divide on the left and on the right with payments. So if I divide on the left with payments and on the right, if I divide payments on the right, then I end up with this factor here. Okay, next thing is I would like to get rid of this interest rate below the line. So to get rid of that on the right, I will multiply with the interest rate. So these two will cancel out. And if I do it on the right, then I also have to do it on the left. Okay, next thing is I'm going to move the term on the left to the right and the term on the right to the left. So I will have on the left, I will have And on the right, I will have and this will now be negative. And then I would like to get rid of this negative 1 on the left. To get rid of that negative 1, I add 1 on the left, and therefore I add 1 on the right. So this part will cancel out. Now what I want to do is I want to get this k on ground level, and I do that by taking the log. So if I take the log on the left, I get minus k. That is on the left, and on the right I will have ln of 1 minus okay, and I actually want to solve for k. So to solve for k, I will divide on the left with this factor here. I will divide on the left with that, and also on the right. So if I divide on the left and on the right, if I divide it on the left with that term, it's going to fall away. And then I divide on the right with that term as well. Sorry, that is now minus k. I divide on the right of that term as well. And that gives me the value of negative k. So to make k positive, I will multiply k with the negative, and therefore I will also have to multiply with the negative 1 on the right. And that gives me the formula for k, the number of payment periods. So in the next slide, we can now just substitute this with the information that we have in example 30. My present value, that's what I've calculated in the previous step. My payment is 15,000 rands. My interest rate and when I solve that, I get 51.95778. And because it's the number of payments, we have to round it up. So we will round it up to 52 payments of 15,000 rands each. In chapter 3, we will see how we will treat an example like this when the number of payments is not a whole number. Okay, so that was then example 30. So we have now solved this formula for the present value, for the payment, for the number of payments k. And then one would also like to solve this formula for the interest rate. We cannot find a simple algebraic method to solve for the interest rate. So you can only solve it making use of your financial calculator. I encourage you to do example 31 on your financial calculator. You have the steps there in your notes, so you should be able to find the interest rate or to solve for the interest rate for an annuity using your financial calculator.